So I'm going to be showing you guys where these famous 30, 60, 90 triangles and 45, 45, 90 triangles in trigonometry come from, since they're used so often. To get the 30, 60, 90 triangle, let's say we started off with an equilateral triangle. An equilateral triangle means that all the angles have the same measure, which is 60. And they also have the same length of sides. So let's say that we want to say that this side is 2, and let's say that all the sides are 2. If we have all the sides of 2, we can also split this triangle down the middle. So once we split this triangle down the middle, we are creating an altitude. And once we're splitting it, this angle becomes a right angle. So now we have 2 triangles here. So let's take a closer look at one triangle. We know that this bottom angle was a right angle and this side was 2. But this top angle, since it was originally 60 and it got split in half, now this is actually 30 degrees because the half of 60 is 30. And we have to identify what this last missing side is. But now that we have a right triangle and we have 2 sides, let's look at this bottom side. The bottom side was 2 as well. If we split that in half, then we're left with 1. So now that we have 2 sides of a right triangle, to find this third side, we can use the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse. So let's fill everything in. We can call a and b anything we want. So let's call that missing side a, plus b. B is that other leg, so that'll be 1 squared is equal to 2 squared. So 1 squared is just 1, so we have a squared plus 1 is equal to 2 squared, that's 4. So let's solve for this. So we can subtract 1 to both sides, and we're left with a squared is equal to 3. Since we have to get rid of the square, to get rid of a square, we can always take the square root. So now we know that a is equal to the square root of 3. So now we know that this last side is the square root of 3. So this is our 30, 60, 90 triangle. So now let's look at the 45, 45, 90 triangle. A 45, 45, 90 triangle is basically an isosceles right triangle. What that means is that it has the same side lengths on the 2 legs. So if we say that one leg is 1, the length of one leg is 1, then the other leg is also 1. But we have to find that third missing side as well. So we can again apply the Pythagorean theorem, but in this case, now we're trying to solve for c. So we have 1 squared plus 1 squared is equal to c squared, because c always represents our hypotenuse. So now 1 squared is just 1, 1 plus 1 is equal to c squared, so we have that 2 is equal to c squared. If we take the square root of both sides, then we know that c is just equal to the square root of 2. So we can fill that into our missing side. So now that we have identified all the components of both triangles, we can find sine of 30, 45, 60, and do the same thing with cosine and tangent. A way to do this is by using SOHCAHTOA, because SOHCAHTOA tells us exactly what sine, cosine, and tangent are. So sine is opposite over hypotenuse. So if we want to find sine of 30, we can go to the angle of 30 and see what is the opposite side. So the opposite side is 1, and then the hypotenuse of the 30-degree triangle is 2. So sine of 30 is a half. At this point, you can pause the video and identify all the other sides for practice, but I'm going to give you guys a shortcut on a way of how to remember this chart without this. Once you have filled out the chart, there are some things that you can notice. So you can notice that all the denominators from all of these sine, cosine of 30, 60, and 45 all have the denominator of 2. So all your denominators will always be 2. And for the numerators parts, for sine and cosine, it goes in an order. It goes from the square root of 1, the square root of 2, and the square root of 3. The reason why I say the square root of 1 is, what's the square root of 1? Well, that's 1, so that stays the same. And for cosine, it actually works backwards. It starts off from the square root of 3, then it goes to the square root of 2, and then it goes to the square root of 1, which is just 1. So that's it for sine and cosine of 30, 45, and 60. The ones that you will have to remember are the ones for tangents. You can also get them from the triangles. So you can go through each one of them and find opposite over adjacent. So tangent of 30 is actually going to be the square root of 3 over 3, which you get after rationalizing. So you will have to remember these. Tangent of 45 is 1, and tangent of 60 is the square root of 3. So this last row, again, you can either obtain from the triangles after rationalizing, it will be these forms, or by remembering them. So this table is important to remember, and it will help us in future problems.